A scheduled maintenance program for the upper and lower jaws of the LaBounty Sabre Series shear is detailed in the Safety Operation and Maintenance Manual. Poorly maintained shear jaws decrease cutting and piercing ability and could eventually cause structural damage to the shear. This condition also causes the hydraulic system to work harder, resulting in premature wear. New blades in proper adjustment will provide the best cutting performance and the longest shear life. It is recommended that the blades be rotated after every 80 hours of use. However, this interval may be shortened or lengthened depending on the material being processed. When processing thin or non-ferrous materials, blade rotation and shimming may need to be done more often. Parts needed for general maintenance and replacement procedures include primary and secondary cutting blades, guide blade, cross blade, shims for the respective blades, blade bolts, various wear parts including the saber tip, and lower wear plates. Work on one blade set at a time. Loosen all blade bolts, leaving them partially installed and threaded into the blade. This will keep them from dropping unexpectedly. Another safe method of blade removal is to insert a bar through a blade bolt hole while removing remaining bolts. If the blades are not loose, a flat bar may be used between the top of the blade and the blade seat to work the blade loose. Tapping on the partially unthreaded blade bolts with a soft-faced mallet may loosen the bond between the blade and seat. Never strike against the blade with a hardened steel tool of any kind. The blade may chip and cause injury. For blade replacement, always use LaBounty-approved blades. Each is quality tested for proper hardness and dimension before shipment. Using blades that are not manufactured to LaBounty tolerances and specifications can hurt performance and cause major service problems. To eliminate unnecessary downtime, LaBounty recommends keeping spare blade sets on hand. To rotate the blades, start by removing the upper shear blades. Wearing a respirator and face shield, grind all rough edges from the blade and clean out the blade seat. Remove the lower blades and adjustment plates and clean them with a sander. Remove guide blade and cross blade. Keep track of all parts and their positions as you remove them. This will be important when reinstalling. Again, clean blades and blade seats with the grinder, removing debris or burrs. Rotate the cross blade to a new edge and place it back in its seat. If both edges are worn, replace the blade. If there were shims behind the cross blade when it was removed, be sure to replace them. Tap lightly on the face of the cross blade with a soft-faced mallet to ensure firm seating and a good fit. Reinstall the adjustment plates. Make sure that the slotted end of the primary adjustment plate is facing toward the shear throat. Rotate the guide blade to a new edge and place it back in its seat with no shims installed. Again, if both sides of the guide blade are worn, replace it with a new one. Install new guide blade bolts and tighten until snug. Make sure the guide blade is seated squarely and firmly in its seat. Do not torque the bolts at this time. The first time the cutting blades are rotated, turn each blade end for end and reinstall in the same seat. Also, rotate the saber tip at this time as needed. For the second rotation, the upper primary and lower secondary blades exchange positions, and the upper secondary blade becomes the lower primary. A new blade is installed into the upper secondary. Install a new saber tip if needed. At this blade rotation, LaBounty recommends that you check to ensure that you have the next new set of blades on hand to avoid unnecessary downtime. For the third and final rotation, turn each blade end for end and reinstall in the same seat. After the third rotation, all four edges will be worn and it will be time to install new blades. Blades should be replaced when all four edges have been worn to a radius of 1/4 inch or 6 millimeters or more. Make sure the upper blades are seated properly upon installation. Use a new set of blade bolts and torque according to the torque charts found in the manual. Place the lower cutting blades into their proper positions without shims. Use a new set of blade bolts and tighten until snug. Make sure the blades are seated squarely and firmly in their seats. Again, do not torque the bolts yet. The final step before putting the shear back into service is to shim the guide blade and lower cutting blades for the proper blade gaps. Do not operate the shear without first doing this. The cutting blade gap is the space between the upper and lower blades as they bypass. This gap is adjusted by shimming the lower cutting blades after blade rotation or replacement has been completed. Keep in mind that if the blades are not rotated regularly, blade shimming will become difficult due to uneven blade wear. The best blade gap for most shearing applications is 10 to 20 thousandths of an inch or 0.25 to 0.50 millimeters, with a maximum allowable gap of 30 thousandths of an inch or 0.75 millimeters. If desired, the gap may be shimmed down to 5 thousandths of an inch or 0.13 millimeters. This may be necessary if jamming becomes a problem, especially when processing thin materials. Prior to checking and setting blade gaps, both slide screws must be backed off so that they do not contact the wear plates. To check the blade gap, slowly cycle the shear closed so the secondary blades in the upper and lower shear begin to bypass, and stop the cycle. Using a feeler gauge between the upper and lower blades, check the blade gap and record it. Another method is to slide the actual blade shims between the blades to determine the amount needed. Continue to close the shear, watching for any possible blade interference during the cycle. Again, stop the cycle when the apex area of the blades begin to bypass and check the gap. If the blades have been properly rotated at the right intervals, the gap in the secondary blades should be even for the entire length of the blade. Once the actual gap has been determined, subtract the desired blade gap from the measured gap. The result will be the amount of shimming needed to obtain the desired gap. It is crucial that the blade gap is maintained to specifications for proper shear performance and long life. To prevent injury, keep hands away while the upper shear is in motion, and never attempt to check the gap while the shear is moving. To install the shims, loosen the blade bolts and slide the shims between the blade adjustment plate and the actual cutting blade to be shimmed. Tighten the blade bolts, but do not torque them yet. Close the shear slowly to ensure there is no blade interference. Recheck the tolerances. It is possible that one of the lower blades will require more shims than the other due to more wear on one of the blades. The total amount of shims that are installed behind the lower blades should not exceed 125 thousandths of an inch or 3.2 millimeters. Exceeding this amount of shims could cause structural damage to the shear. When the lower blades are properly shimmed and the gap is correct, torque the blade bolts to the proper torque as outlined in the manual. Located in the lower shear on the opposite side from the cutting blades, the guide blade makes contact with the wear surface of the saber tip, which supports and keeps the upper shear in alignment while cutting. The guide blade gap should be approximately 10 thousandths of an inch, or 0.25 millimeters. The gap between the saber tip and the guide blade must not exceed 30 thousandths of an inch, or 0.75 millimeters. If this gap is too wide, the upper shear will not be properly supported during shear operation, and you may notice materials sticking, jamming, or not being processed as easily as usual. This gap should be checked daily and adjusted if necessary. To check the gap, close the shear until the wear surface of the saber tip begins to bypass the guide blade. Use a feeler gauge to check the gap and record it. Close the shear in steps and check the gap at different spots along the wear surface of the saber tip. For personal safety, do not attempt to check the gap when the shear is in motion. Find the smallest gap along the wear surface of the saber tip and mark it. If the gap at this spot exceeds 30 thousandths of an inch or 0.75 millimeters, it will be necessary to shim the guide blade. Guide blade shims are provided with a new shear. To determine the amount of shims to use, subtract the desired gap of 10 thousandths of an inch or 0.25 millimeters from the smallest gap that was recorded earlier. To shim the blade, loosen the guide blade bolts and move the guide blade out far enough to slide the shims between the blade seat and the guide blade. If all 5 shims are installed and the gap is still too wide, it will be necessary to rotate or replace the guide blade. Once the shims are installed, use a new set of blade bolts and tighten until snug. Check the blade gap again to make sure it is within specification, and then torque the bolts according to the torque charts found in the manual. If the guide blade gap is still too wide with a new guide blade and a full set of shims installed, the saber tip must be rotated or replaced. Guide blade adjustment is critical for proper operation of the shear. Never weld the guide blade into the guide seat.